Alright, so x plus 3 goes on the outside. 3x cubed plus 23x squared plus 57x plus 48. I've got them all. Don't need to put any placeholders in. Okay. First one is 3x squared. So that's going to be 3x cubed plus 9x squared. Change my signs. That gives me 14 x squared. Drop it like it's hot. That's going to be plus 4. Whoa. Wrong color. Rookie mistake right there. Okay. So then that's going to be 14x here. X plus 3. That's going to be 14x squared plus 42 x. Change the signs. That gives me 15x. Drop it like it's hot. And then that's going to be, there's going to be 15 here. So then this is going to be 15 times x plus 3 is going to be 15x plus 45. Change the signs. Leaves me with that. Is x plus 3 a factor? Why not? Because there's a remainder, not a factor. Because of the remainder. Okay? If this were 0 right there, then it would be. But it's not, so it isn't. Okay? Now, long division is just that. It's long, and it's division. Okay? So, there's got to be an easier way. Well, today, we're going to learn that easier way, okay? And that's something called synthetic division, okay? So we have this short and interesting video for you to watch.
Wow, you guys really love that old school long division of polynomials. But if you had a fancy way, yeah, like ketchup, right? I'm talking about maybe motor oil. Synthetic motor oil? No, synthetic division. Yes. Here's our topic. Right. What do we need to do? We need to be divided by special linear factors in order to use synthetic division. So let's talk about how we're going to get into this game. All right. Special linear factors. Yeah, something like these guys. Okay. This is not a special linear factor. Why? Because my leading coefficient of my variable is not 1. What makes a special linear factor? A special linear factor has coefficient 1 and degree 1. An example of a special linear factor is x minus 2. Okay, this is x minus c. Okay, what goes outside of our box? The opposite of c, or whatever is going to make our denominator 0. I'm ready for an example. Up here, yes. And we're divided by a special linear factor. Yeah. So then, okay, zeros go outside of the box. What makes that denominator 0? Minus 1. Zeros go on the outside. coefficients go on the inside. Coefficients are the numbers in front of the variables. Here we go. I'm going to put a 1, I'm going to put a 3, and I'm going to put a 2. Oh, this is actually log division without the actual coefficients, and we need our special linear factors. So then what do I first do? Drop it like it's hot, drop it like it's hot. Minus 1 times 1 gets me a minus 1. Very nice. 3 minus 1 is 2. Okay. Minus 1 times 2 is a minus 2. Oh, and our remainder is 0. What does this mean? This means that x minus 1 is a factor of x squared plus 3x plus 2. You're going to be using something called the factor theorem to determine that. Yes, but that's neither here nor there. Where is it? Yes. We're taking 1 degree out of the numerator. It was a degree 2. So now I want to write my answer as 1 degree less than 2, which is 1. X plus 2 is going to be the quotient of those two polynomials. And then what? And a flower. Now I'm up here. Okay. Yes. Am I dividing by a special linear factor? Yes. So what goes on the outside? Zeros go on the outside. What's a 0? Anything that makes that polynomial 0. What's going to make this polynomial 0? 1 is. Okay. And a different color. Yeah, 1 is on the outside. What goes on the inside? My coefficients. Yes. A 1 goes in there, a 2 goes in there, a minus 3 goes in there, and a 12 goes in there. Okay. So then, I drop it like it's hot, drop it like it's hot, you know, snoop, dun, dun, yeah, whatever. That was my song with one of my ex-girlfriends. Yeah, and yeah, I went away, and I'm not gonna finish that story. Anyway, she dropped me like it was hot. Oh, messed up, right? She was a horrible person. No, she wasn't, really. Yes, here's a 1. This one times that one, put it there. That's a 1. 2 and 1 is 3. Tee-hee. This one times that one, put it there. That's 3. Tee-hee. Adam. 9. Yes, this one times that one, put it there. 0. Oh, Adam, and you got 12. Oh no! What does this mean? Let's go through. Rewrite our quotients. Yes, I had degree 3. This is gonna take it down a notch. I wish you'd take it down a notch. Hey, whoa. So instead of degree 3, it's now gonna be degree 2. So then, this is gonna be x squared plus 3x plus, no constants, but I do have a remainder. And how do I write that? I write it remainder over divisor. X minus 1. Fun. And then what? And a flower. And when I said I went away, I wasn't talking about like to the yeah, no. I had to go do some work somewhere else. Here we go. What makes this non 0? 2. Yes. So I put a 2 on the outside. And then I put the coefficients on the inside. I put a 1. Then I put a 0. Why? Because I need a placeholder for my x to the third term. Yes. So 0x to the third plus 0x squared minus 1x plus 2. Okay. Oh, I need placeholders. On the outside, zeros. And then on this first one, drop it like it's hot. There's a 1. 1 times 2 is 2. Very nice, Adam. 2. 2 times 2 is 4. Sure, Adam. 4. 2 times 4 is 8. Great, Adam. That's a 7. 2 times 7 is 14. Adam. That's a 16. Okay, that's my remainder. I'm dividing by a linear factor. I need to take it down a notch. This is x to the third plus 2x squared plus 4 x plus 7 plus remainder 16 over divisor x minus 2. Look at that one. Oh, yes. Yeah, I do think it's a hammer. Because it's hammer time? No. Because we nailed it.
before we go into these examples on the back side, I want to talk about, on the bottom of your note sheet, I want to talk about what we have to do here with linear factors. Okay? Or with, I should say, with synthetic division. What were some of the things that you took out of that video? I know he was a little kitschy. Okay? But what's something you took out?
The number on the outside is equal to 0 where you divide it by.
So the number on the outside is a 0. So you set your divisor equal to 0 and solve. Okay, what else? The setup was a little different. How was the setup a little different?
You kind of made it it kind of looks like a chart.
Okay, so we had outsides and insides, right? So what went on the inside then? Okay. Then what did he do? Drop what like it's hot? The first one, right?
Oh, yeah, first.
Okay. And then after that, multiply, kind of like long division, right? Where you multiply and then added and,
He did it by diagonals.
okay.
Multiplied.
Okay. So then it's multiply, add, repeat kind of a thing, right? Until you get to the end, and then what? Converted it back to a polynomial. What was the big thing that he did to convert it back to a polynomial? We drop the degree by 1. Okay? So, let's do that warm-up problem, because that warm-up problem works, right? Is that a special linear factor? Yeah, okay, all right. So, we're going to do, it was 3x cubed plus 23x squared plus 57x plus 48, and all of that is going to be divided by x plus 3. Now, we just got an answer for that, right? What did we get for an answer?
3x squared plus 14x plus 15 remainder 3.
So that would have been our answer if we would have done it long division, right? We were just asking for a factor when we did it the first time, but that would have been our polynomial answer, right? Okay, so zeros go on the outside according to him, right? So what goes on the outside of this one?
-3.
-3 is going to go on the outside because we set x plus 3 equal to 0. We get -3. Then, what goes on the inside? 3, 23, 57, 48. Okay. First thing that he did was dropped it like it's hot. Okay. So there becomes the 3, right? Then what? He multiplied those two together to get -9. Then he added those two together to get 14, right? Then he multiplied those two together, right? So that got us negative 42. Added them together. Got 15. Then, oops, wrong color. Okay. And then got 45, or excuse me, negative 45. And then that gave us 3. Right? So then this 3 becomes, because now then I take this exponent right here and I drop it down 1, right? So then this becomes 3x squared plus 14x plus 15 plus my remainder was 3 over x plus 3. And we get the same thing. With me? Now, what are the downfalls of synthetic division?
You can only do it.
If you're dividing by not by a 0, what kind of a factor can we only use synthetic division on?
The leading coefficient is 1 and the degree is 1.
He said that, but I'm not worried about that because we can do fractions too. The only way is if this right here is, that has to be linear. It has to just be an x. Yep. It can't be an x squared or an x cubed. Okay? Which we will get into in higher level stuff. Okay? So that only works if that's a linear term. Okay? All right. So, example number 1. You do it synthetically right now. I'm going to do it long division while you're doing it synthetically. Okay? So that we end up getting the exact same thing. So this would be x squared, x cubed minus x squared. Change. X squared. Change lives. I get I get x squared minus 2x minus 3. Yes? Synthetically, like, x minus 1 gives me a 0 of positive 1. My coefficients are 1, negative 3, negative 1, and positive 3. Okay? So I drop the first one. Multiply. Add. Oops, that's a bad thing. Multiply. Add, multiply, add, which gives me a remainder here of 0, right? This was an x cubed, so this gets dropped down to x squared minus 2x minus 3. It is not what it is. But it's limited in what you can do with it. Okay? Alright? Oh, we did that one already. Alright? So, try those two. Alright? Which I think are the next two on your sheet. x minus 4 gives me a 0 of 4. Coefficients 1, 2, negative 5, and 16. Cubed, squared, single, none. Okay? Drop it like it's hot. 1, multiply is 4. Add is 6. Multiply is 24. Add is 19. Multiply is 76. Add is 86, 92. Right? Yes? Okay. This was a cubic, so that means I drop this down to an x squared plus 6x plus 19 plus 92 over x minus 4. Yes? Back me up. If I was artistic enough to draw the hammer, I would draw the hammer. Because we nailed it. 0 here then would be 2. 1, negative 4, negative 3, and 6. Okay? 1, 2, negative 2, negative 4, negative 7, negative 14, negative 8. Yes? What?
It goes from 4 to 2.
Oh, it was 4. Oh, so we can't do it that way. What do we always got to look for? Got to look for those exponents. Okay? All right? So in your brain here, you're really thinking plus 0 x cubed. A good rule of thumb is you take the degree of this one, which was 4, right? Right? Okay? So you take that 4, add 1 to it. 5, I'll show you where the 5 comes in. Okay? So this is 2, 1, 0, negative 4, negative 3, and 6. And now I've got 1, 2, 3, 4, 5. It's a plus 1. Okay? Whatever your degree is, you should have one more coefficient than that. Okay? Alright? So now 1, 2, 2, 4, 0, 0, negative 3, negative 6, 0. Yes? Okay. So this becomes, it was 4. I'm going to drop that down to x cubed plus 2x squared plus 0x minus 3.
We wouldn't get points marked off if we put plus 0x.
I would not take points off. Okay. Try those two. So my 0 here is negative 3, 1, 8, 7, and 5. Degree of 3, that means I need 4 coefficients. Got it. Okay. 1, negative 3, 5, negative 15, negative 8, positive 24, and 29. That gives me x squared plus 5x minus 8 plus 29 over x plus 3. Yes? Yep. X minus 1 gives me a 0 of 1. Coefficients of 1, negative 3, 6, negative 12, and 8. degree of 4, 5 coefficients. That's good. 1, 1, -2. -2 is 4. 4 is -8. -8 is 0. Drop 1, so that becomes x cubed minus 2x squared plus 4x minus 8. So on this particular one, that first one, the left one, x plus 3 is not a factor, correct? Because there's a remainder. But in the second one, x minus 1 is a factor because the remainder is 0. Okay? All right? Before you leave, I do have